Hello everyone, and welcome back to the Fluctus Channel. The V-22 Osprey became one of America's most unusual military aircraft because it does not fly like a normal helicopter and does not operate like a normal airplane. Its two massive engine nacelles rotate upward for vertical takeoff, then tilt forward in flight, allowing the aircraft to lift from tight landing zones, cross long distances at airplane speed, and arrive where runways are not available. For Japan, a country made of thousands of islands and surrounded by some of the busiest waters in the world, that combination became more than an aviation experiment. It became a practical answer to rapid movement, disaster response, and island defense. The Marine Corps brought V-22 Ospreys to Marine Corps Air Station Iwakuni in 2013, marking a major step in forward-deployed tiltrotor operations in Japan. Each arrival required careful ground coordination. Crews guided the aircraft across the apron, kept safe distance from the wide rotor arc, and positioned support equipment before post-flight checks began. The Osprey can carry 20 FOUT combat-equipped troops, and its value comes from moving them farther and faster than the older CH-46 Sea Knight helicopters it replaced, while reducing delays during urgent island missions. Japan's purchase was historic because it became the first foreign customer approved for the V-22. The deal centered on 17 V-22B Block C aircraft. These were not simple aircraft purchases. They required training pipelines, maintenance planning, spare parts, basing arrangements, and close coordination with American units that had already learned the platform's demanding operating rhythm. For the Japan Ground Self-Defense Force, the Osprey offered a new way to move soldiers from mainland bases to island landing zones without waiting for long runways or large ports. That capability becomes clearer during joint drills. In Exercise Iron Fist 2020, U.S. Marines and Japan Ground Self-Defense Force soldiers practiced fast rope training from an MV-22B at Camp Pendleton. Soldiers moved to the rear ramp, clipped in under supervision, gripped the rope, and descended in sequence while the aircraft hovered above the landing point. And the team built combat power on the ground before the aircraft lifted away. For amphibious units, this method is useful when the landing zone is too small, too rough, or too exposed for a full touchdown. The same aircraft also supports humanitarian missions. During relief work near Kumamoto in 2016, Marines, sailors, and Japan Maritime Self-Defense Force members loaded supplies into an MV-22 aboard the Japanese ship JS Hyuga. Boxes were staged by priority, passed along the deck, secured inside the cabin, and balanced so the aircraft could depart safely. Once loaded, the Osprey could launch from the ship, tilt its nacelles forward, and carry aid inland faster than trucks moving through damaged roads. Takeoff is one of the aircraft's most recognizable moments. The engines hold vertically as the aircraft rises, the landing gear clears the ground, and the nacelles slowly rotate forward as speed builds. The sound changes as lift shifts from rotor-driven hover to wing-borne flight. In replenishment missions, that speed allows marine crews to reach ships at sea, including submarines needing supplies far from port. For transporting people, the rear ramp turns the aircraft into a flying connector between bases, ships, and isolated landing zones. Behind every mission is heavy maintenance. Crews inspect rotor hubs, nacelles, hydraulic lines, wiring, panels, engines, and the complicated conversion system that makes tilt-rotor flight possible. Panels are opened, components are checked, faults are traced, and functional tests confirm that the aircraft can safely lift, tilt, and fly again, even under pressure every time. Mechanics also watch for corrosion from sea air, blade damage from constant operations, and software warnings from the cockpit. For a tilt-rotor, readiness is not one inspection. It is a chain of small checks that protect every crew member before the next mission. It is the hidden labor behind every dramatic departure, fast rope drop, supply run, and safe return to base in Japan's region, where distance, weather, islands, and alliance missions demand an aircraft able to move quickly from shore to ship and back again during demanding operations. Japan's interest in the V-22 also fits into a broader defense story. After World War II, Japan built its modern military around the self-defense forces, with strict limits on offensive operations, but a strong focus on protecting its territory, airspace, sea lanes, and population. Over time, the security environment around Japan became more complex. Remote islands, missile threats, submarines, drones, and fast-moving maritime activity pushed Japan to invest in systems that could detect danger earlier and respond faster. This is where Japan's defense industry becomes important. The country does not rely only on imported equipment, it has major industrial companies, advanced shipyards, precision electronics firms, and a government agency structure built to manage research, development, and procurement. The Acquisition, Technology, and Logistics Agency, known as ATLA, was created to strengthen how Japan develops and buys defense equipment. It connects technical research, industrial production, testing, and long-term support, which is exactly the kind of organization needed for advanced aircraft, missiles, sensors, and future weapons. Japan's air defense has traditionally depended on radar networks, fighter aircraft, surface-to-air missiles, and close cooperation with the United States. Its ground defense depends on mobile units that can protect islands, move quickly, and respond to landings or disasters. The V-22 serves that pattern by giving ground forces speed and reach. But Japan is also preparing for threats that move faster than aircraft, including drones, rockets, and hypersonic weapons. That is why directed energy weapons have attracted attention. Laser guns are designed to use concentrated light instead of explosive ammunition. In basic terms, the system detects a target, tracks it, holds a beam on a vulnerable point, and lets heat damage the object. Against small drones, that could mean burning through a wing, motor, sensor, or control surface. The challenge is power, cooling, atmospheric conditions, and keeping the beam steady on a moving target. Even so, laser weapons are attractive because each shot can be cheaper than firing a missile, and the magazine depends mainly on available electrical power. Railguns follow a different idea. Instead of using gunpowder, an electromagnetic railgun sends electric current through rails and accelerates a projectile at extreme speed. Japan's Ground Systems Research Center under ATLA has worked on this technology as part of research into longer-range, high-speed defensive firepower. The concept is simple to describe but difficult to master. A power system charges, current passes through the rails, magnetic force drives the projectile forward, and the round leaves the barrel at high velocity. The same forces that make it powerful also create heat, wear, and engineering stress. Together, these programs show why Japan was trusted with the V-22. It is not only a buyer. It is a disciplined defense partner with manufacturing depth, strict operating procedures, and a long record of integrating American equipment into its own island defense strategy. That confidence matters when Washington releases sensitive platforms because the aircraft must be protected, maintained, and used inside a trusted alliance network with disciplined crews, technicians, and leaders able to manage advanced systems. Japan's ability to operate advanced American aircraft is also strengthened by the aircraft it builds at home. One of the clearest examples is the Kawasaki P-1, a Japanese maritime patrol aircraft developed for the Japan Maritime Self-Defense Force. Unlike patrol aircraft converted from civilian airliners, the P-1 was designed from the beginning for long-range maritime surveillance. It replaced the older P-3C Orion, giving Japan a modern aircraft built around the specific job of watching the surrounding seas. The reason this matters is geography. Japan sits beside deep water, narrow straits, busy shipping lanes, and areas where submarines can move quietly between the Pacific and nearby seas. A maritime patrol aircraft must search wide areas, remain on station for long periods, and coordinate with ships, helicopters, and command centers. The P-1 was built for that mission. It is about 38 meters long, has a wingspan of about 35.4 meters, and carries sensors and mission systems designed for anti-submarine and anti-surface warfare. A typical patrol begins long before takeoff. Mission crews study the search area, expected contacts, weather, sea conditions, and likely submarine routes. On the flight line, technicians inspect the engines, control surfaces, sensors, sonobuoy systems, and mission equipment. Once airborne, the aircraft flies to its patrol zone and begins building a picture of the ocean below. Radar searches the surface for ships. Electro-optical systems help identify contacts. Acoustic equipment listens through sonobuoys dropped into the water. Each buoy becomes a listening point, transmitting sound data back to the aircraft. Submarine tracking is a slow, careful process. The crew does not simply look for a shape under the water. They study noise, movement, patterns, and changes in the acoustic environment. A submarine's machinery, propeller, and movement through water can create signatures. The aircraft drops more buoys to narrow the search, compares signals, and works with surface ships or helicopters if the contact becomes important. The P-1's mission systems help manage this information so the crew can decide whether a contact is harmless, suspicious, or a real threat. Its airframe, engines, and patrol systems were domestically developed, and its fly-by-optics flight control system uses optical fiber technology to reduce electromagnetic interference. That matters in an aircraft packed with sensitive sensors. The result is a highly capable platform designed not just to fly, but to listen, search, classify, and coordinate over the sea. This is why Japan's V-22 purchase stands out. It gives Japan vertical lift, speed, and island reach. Joint drills with U.S. Marines build shared tactics. Relief missions prove its value beyond combat. Maintenance keeps the complicated tiltrotor ready for difficult missions in demanding island conditions. At the same time, Japan builds patrol aircraft, studies lasers, and develops railgun technology. Together, these capabilities explain why Japan became the only foreign nation approved to buy and operate America's advanced V-22. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.